we need to discuss the importance of type 1a supernovae and the accelerated expansion of the universe. Now, a type 1a supernova is a white dwarf which is next to its binary partner. The mass is being sucked from the partner into an accretion disk which goes around the white dwarf. It becomes unstable and will explode, and this is a type 1a supernova. So these are caused by small stars, which are basically white dwarfs. The matter falls onto this accretion disk, it falls in, it will explode, and it will cause an emission of radiation which is 10 to the 9 times as bright as the sun. So this supernova is very visible. Astronomers can identify these 1A supernovas because they happen in the same way by this accretion method, and they have more or less the same luminosity. This gives them the quality of being standard candles. If you can see how bright the star is, and you can see how bright you know it's supposed to be, you can work out how far it is. And this is better in many ways than the other standard candles that astronomers use, like Cepheid variables, because they're much brighter. So you can see distances which are much further. And because with distance comes passage back in time, it means you can look further back in time. Now, this is the way we understand the expansion of the universe. It says here that this diagram shows the rate of the expansion of the universe over 15 billion years. You can see from the curve that it started off with a very rapid expansion to start with, which kind of started to slow down, and then we get to the point where we are now, and we can observe by looking at these supernova, these 1A supernovas, that now the universe is starting to expand, or rather to increase its expansion, another accelerated expansion. And we say this is due to this mysterious dark matter, or this dark force, or dark energy that is pushing the galaxies apart. The universe underwent a massive accelerated expansion after the Big Bang, but then this expansion has slowed down. This initial expansion was called the inflationary period, but then after that it slowed down. It was expected that eventually it might actually stop expanding and could even collapse back on itself. By looking at observations of type 1a supernova, we have seen that the universe did actually slow its expansion, but now it's started to accelerate its expansion again. And this is due to a mysterious force called the dark force, or dark energy. Here we see the expansion, which is fairly linear, but then it starts to expand even faster as it becomes more and more shallow. Here we have another graphic which illustrates this. We start with a very rapid expansion in the inflationary period. Then it slowed down a lot. It's still expanding, but now it's expanding at a constant rate. But with time, what is happening is that this rate of expansion is starting to increase. So in other words, the universe is accelerating away, when it should be decelerating. The mass should be pulling it back together, but there's something else which is stronger, which is pushing it apart. And we put this down to dark energy, or the dark force. What causes this dark force? What causes this dark energy? Could it be